Hello, Algebra 2 CP. Hopefully, you're having a good day so far. Yesterday, we talked about greatest common factor and difference of two squares. Today, I'd like to continue the discussion of factoring by really getting into the meat and potatoes of factoring, that being factoring trinomials. All right, this is like your main prime time Algebra 2 factoring technique that you will really need to know how to do in order to have success in the next several units going forward, because factoring is something that doesn't go away. It's not going to go away in the rest of Algebra 2. It doesn't go away in pre-calculus or calculus. You use factoring all of the time. And factoring trinomials is really the big deal factoring stuff. So if you have any questions on this, please feel free to reach out, and I'm going to try to do my very best to give you a proper explanation of how this works. So to get started, though, what I would ask you to do is, if you take just about a minute, see if you can pause the video and distribute these two things together. I know you know how to do it, but it's important that we talk about distribution first because it ties directly into how the whole factoring technique takes place. Take a minute, pause, see if you can make that happen. All right, I assume by now that you've done that. So in order to just go through it with you, to distribute, I would do 5x times x is 5x squared. 5x times 2 plus 10x. 4 times x plus 4x. 4 times 2 plus 8. Notice we would then combine the two like terms in the middle, and we'd end up with 5x squared plus 14x plus 8. Okay? And I think it's very important to note how these terms actually come about. I mean, I know you should know how to distribute at this point, but notice that this 5x squared right here, right, really comes from doing 5x times x. It comes from multiplying these first two terms together, correct? This last term, the plus 8, really comes from multiplying these last two terms together, the plus 4 and the plus 2, correct? And you see that this middle term of 14x, this middle term really comes from these middle two multiplications. When you do the 5x times the 2 and the 4 times the x, and then combine those like terms together, you get 10x from the outer multiplication, 4x from the inner multiplication, and together those combine to give you 14x. Okay? Again, that may seem like, Mr. Giorgio, why are you telling me that? I know that. But you're going to see why that is particularly important now when we go in reverse, because factoring is really the opposite of distributing. It's just taking the same thing and going in reverse. Take a look. We're actually going to start by breaking down that exact trinomial. 5x squared plus 14x plus 8. Okay? Now, there are a lot of factoring techniques out there that you may see if you go and search the web in the wide world of factoring. You may see stuff on trying to differentiate between leading coefficient of 1 and leading coefficient of not 1. You may see stuff called the box method, where you're trying to break it down into a grid, essentially. You may see something called the cross method. You may see factoring by grouping. You may see all sorts of other. AC method is one that I really don't like. The rainbow method, believe it or not, that is actually a factoring technique called that. You know I don't like that. You could probably already tell. But what I do like is what's called guess and check. But we can take very educated guesses, and so that we can limit our factoring possibilities. It is by far the fastest and most efficient way to factor. And it just really requires an understanding of this distribution process. But since we know how to do that, consider this. Pretend we don't know that this breaks down to this. It is obviously going to factor down to that. But I know that my 5x squared plus 14x plus 8, the goal is I want to split it up into two binomial factors. All right, two sets of two things. In order to do that, again, think of how we get this. This first number, 5x squared, is going to come from this number times this number. So what are all your possibilities for getting 5x squared? Well, there's really only one. If you have to have x on both, you have to have a 5x times a 1x. Right? That's the only way that you're going to end up with a 5x squared, is if you have a 5x times a 1x. So we need to have a 5x here and a 1x here. Correct? How can we get this plus 8 at the end? Well, if you remember, this plus 8 comes from multiplying this and this together, correct? The fact that it's positive means that either both of these signs have to be positive or both of these signs have to be negative, because positive times a positive will give you a positive and negative times a negative will give you a positive. However, it wouldn't really make sense to introduce any negatives into this problem, because if you notice, my middle term has to come out to be a positive number as well. So why would I throw in negative negative when I need to somehow get positive in the middle? Do you see that? That middle goal being a positive number is a good indication that we're going to need positive and positive. And then lastly, think about your possibilities for 8. Well, we could do 1 times 8, or we could do 2 times 4. So how can I arrange these numbers in such a way, either the 1 and 8 or the 2 and 4, such that I will get this 14x when I multiply these outer terms and inner terms together? How can I do that? Well, if you might think about it for a little bit, and you might say, ooh, well, I could do 5x times 2 to get 10x, and then 4 times x to get 4x, and 10x plus 4x would make your 14x. Do you see that? If you pick this pair in particular, and you say that this is our plus 2 and plus 4, then it works out exactly fine. We know 5x times x gets 5x squared. We know 4 times 2 gets 8. And this outer multiplication gives us 10x. The inner multiplication gives us 4x. That adds to your 14x. And so that's exactly how you would factor that down. All right? Not bad, right? It takes very little work, I think, if you understand the distribution process. Now, what if you messed it up? What if here you said, well, let's do 8 and 1? Well, first of all, I'd be discouraged from doing that, because you know you're going to do 5x times 8 is 40x. How the heck are you going to recover from that to get to your goal of 14x, right? But if you happen to do that, it's really just a minor inconvenience, in the sense that you'd be like, oh, that one didn't work. Let me try a different pair here. And so what if you did 4 first and 2 second? Well, if you did that, you would get 20 plus 2x is 22x. Not quite our goal of 14x. Just try again, right? It doesn't really take too much time in order to recover. Okie doke. Let's try another one. Now we don't know the answer ahead of time. Ready? How about something like this? X squared plus 19x plus 90. Once again, the goal is to split this into two binomial factors like this. I know, because based on how distribution works, I know that my first number times my first number is going to equal the x squared. So what are my possibilities for that? Well, my possibilities for that is to get 1x squared, I need 1x and 1x. That's it. There's no other possibility that I can really use, right? So I would start with 1x and 1x. See that? I know that my last two numbers need to multiply to that 90. This number and this number here need to multiply to the 90. Considering that 90 is a positive number, I would need either plus and plus or minus and minus, because positive times positive or negative times negative, that's how we can get a positive here. Well, what is it going to be? Well, I'd probably, again, pick positive and positive, because my middle goal is to equal a positive thing. So it doesn't really make sense to start throwing negatives in there. How the heck would we get a positive 19? Let's do plus and plus. And now there's a lot of possibilities for 90, but you may already be able to see them. Think about the fact that we have 1 and 90. How the heck is that going to get us to 19? 2 and 45. 3 and 30. Let's see, there's probably some others. 6 and 15. I believe we also have 9 and 10. I think that's it. That's at least the ones we're going to care about. There might be others. I don't know. Off the top of my head, that's 5 and 18, right? Throw that in there too. 5 and 18. Okay. Well, think about it. That seems like a long list of possibilities, but we can really limit that list by focusing on our middle goal. Again, I kind of said it already. If I did 90 and 1, how the heck is that going to help me get 19? There's no way that that's going to work out, so we don't even have to test that possibility. Same thing with 2 and 45. Put 45 and 2. There's no way we'll get 19. And 3 and 30 is very similar. Like they're just too large of values to actually work out here. What possibility is going to work though? Well, what's going to work is 9 and 10. Because if you notice, I do this outer multiplication, x times 10 would be 10x. Inner multiplication, 9 times x, 9x. And that gives you your 19x. So this right here, x plus 9 times x plus 10, is the factored form of this. All right? Something you may notice about this is when both of these are the same, like 1x and 1x, for example, it doesn't matter what order you put these in. When they're different, though, it does. Like if I put the 2 here and the 4 here, that's not going to work out the same. Okay, so just something to keep in mind. All right, let's do some more. Ready? How about 5x squared minus 28x plus 32? All right, I like this problem a lot. Okay, we're going to break down our trinomial into some factors. Again, these are called trinomials. I don't think I mentioned that. Trinomial means you have 3 terms in a row. Okay, if I want to break this down into factors, again, the first one is going to come from 5x times 1x, right? That's the only possibility we have to get 5x squared, 5x and 1x. So I'm going to put a 5x here. Pen's dying a little bit. And a 1x here. I think it'll make it to the end, though, of this example anyway. Then we might have to ditch the colors. Over here, we would then say, I know these last two numbers have to multiply to get me 32. It's a positive 32, so I either need plus and plus or minus and minus. Here, given that my goal is to get a negative 28, I definitely would need negatives here now. Because there's no way, if I made everything positive, how the heck could we get a negative 28 in the middle? It just wouldn't ever happen, right? And now I would start to think, oh, well, what are my possibilities for 32? I have, let's see, 1 and 32. We would have 8 and 4. We would have 2 and 16. I think that's it. Okay? But let's start to think about it. How the heck could that work out? How can I get 28 in the middle? Again, if you happen to pick a wrong possibility, like say you said, oh, let's do 8 here and 4 here. Well, if you did that, 5 times 8 would be 5 times negative 8, negative 40x, minus 4x would be negative 44x. That wouldn't quite work out. But see, like that's only like a 5-second setback. It doesn't mean like you're doing the whole problem wrong. Let's just pick another one. Maybe we'll do 4 here and 8 here. And if you notice, that would work out because you'd have 5x times negative 4, negative 20x, negative 8 times 1, minus 8x. Together, those would make minus 28. Again, I want to emphasize the fact that you could once again eliminate a lot of possibilities here. It's not just random guess and checking, it's educated. We don't, like 1 and 32 would probably not work, right? Because 32 is just too large, okay? 16 is kind of the same deal. You might be like, well, it might kind of work if I put the 2 here and the 16 here. And that's fair enough because 5 times 2 would be 10, 16 times 1. Like maybe that could work out. But certainly it wouldn't make any sense to put the 16 here. If we put the 16 here, 5x times 16, like that's way too big to get our middle goal of negative 28. Make sense, hopefully? Let's try some more. We'll do maybe 3 or 4 more. How about if I have, let's throw some negatives in there. 4x squared minus 4x minus 80. Okay. I like this problem a lot because something you may notice at the very start of this problem, even though you might want to get in there and start factoring right away, something you may notice is, wait a minute, look at those 3 terms. They all have a greatest common factor, and absolutely they do. You could take out, before you get started, and I highly recommend doing so, take out a greatest common factor of 4 and break this down to be x squared minus 1x minus 20. That saves you a lot of grief in the long run to take out a greatest common factor right away. So what I'd recommend doing is at the start of any of these trinomial factoring problems, always, always, always look for that GCF. Look for that greatest common factor. All right. But now that we did that, the rest of the problem is going to work pretty much the same as what we've seen before. Now, when I'm breaking this down, I'm going to have this 4 on the outside of my parentheses because that was my greatest common factor. Just kind of hangs out over here. Let's think about our numbers now. I need these first two are going to come from this x squared. What's my only possibility? Well, it's going to be x times x. That's the only way I can get x squared. This 20 is going to be coming from these last two numbers now, right? Kind of ditch the colors here, these last two. Well, keep in mind that the fact that it's a negative 20 means what do I need my signs to be a negative 20? Well, I'm going to need, in order to multiply to a negative, we need one of each. One positive and one negative, right? So we can put a plus here and a minus here. Notice in this particular case, it doesn't really matter if we put plus with this one and minus with this one or vice versa, because x and x are the same. If they're different though, which we'll see in the next example, it is going to matter where you put that negative. All right, but let's keep going for now. I would say, well, what are my possibilities for 20 that can make this work? We could do 1 and 20. We could do 2 and 10. We could do 4 and 5. Given that your goal is to get negative 1 in the middle here, how could you possibly arrange your factors such that this works out? You can do a minus 5 and a plus 4, because again, these outer multiplications would be negative 5x plus 4x would give you your negative 1x. All right? So the point of that problem, again, take that greatest common factor. Very, very important. All right, let's do a couple more. How about something like this? If I have, let's do 6x squared minus 26x minus 20. Try to factor that down. Again, observation right off the bat, greatest common factor, right? We look just like this problem. I would see, ooh, I could take out a greatest common factor of 2. If I do that, that gives me 3x squared minus 13x minus 10. And that's just much easier to deal with. Why not deal with smaller numbers if we can, right? And then if you don't, at the very end, you'll have to take out common factors. It's way easier to do that at the beginning, in my opinion. So if we're now dealing with this, again, we want to break this down to our two sets of parentheses, like so. I have this 2 sitting out in front. Don't forget, that greatest common factor of 2 doesn't just disappear. It's still there. This first number is going to come from the first term here, this 3x squared. How can I get a 3x squared in that first position? Well, I need to multiply by 3x and 1x. That's the only possibility for me to get 3x squared. I would need 3x and I would need 1x. Think about the last term now. We know the last two numbers are going to come out to be that negative 10. The fact that it's a negative means that I'm going to need 1 plus and 1 minus, right? How do you know which is which? Well, that's a great question. The short answer is you don't. But the longer answer is that you can sort of increase your odds of getting that right, taking that guess of is this plus or is this plus, is this minus, by looking at my goal in the middle. And I would say, ooh, well, my goal is to get a negative 13. Like a negative number is my goal. So if I have a negative goal in the middle, I probably, I'm not saying definitely, but I'm saying I probably want to pair the negative with the bigger number. Because if you notice, 3x times this will result in a bigger negative quantity, working me closer to my negative goal. All right, so hopefully that makes sense as to why you decide to do that. Not saying it's 100% right. You may find that it's just not working out and you need to switch those signs. But that's sort of my logic towards this, is I'd say, well, since I have a negative goal in the middle, I'm going to pair this 3x to multiply with a negative number, because that's going to be a bigger negative quantity working towards my negative goal as opposed to this. Okay? Now I would break down 10, because we know this last value has to be factors of 10. So we got, let's see, 1 and 10 and 2 and 5. How can we get a negative 13x in the middle there? Well, I'd say, ooh, look, 3x times negative 5 is going to be negative 15x. And then 5 and 2 make 10. 2 times x is plus 2x. Negative 15x plus 2x is my negative 13x. So this right here is the factored form of that. Kind of neat, right? See how quick it is, especially when you get good with the practice of the factoring and multiplication, and you get really the hang of that. It can go really, really, really smoothly. All right, really, really smoothly. All right, let's do one more. No GCF, no funny business in this one. Ready? Something like this. If I have 7x squared plus 64x minus 60. Big numbers, but no GCF. Okay? We want to break this down to two sets of parentheses. The first number comes from my 7x squared. Well, 7x squared, we can break that down to be 7x times 1x. It's really the only way that we could break that down, right? Is to be 7x times 1x. Put our 7x here, our 1x here. I have negative 60 now. Well, the fact that we have a negative means we should have one positive and one negative to multiply to a negative value. Again, I look at my goal in the middle and I see, ooh, a positive 64. So I'm probably going to want to pair the plus with my 7x, because you see when I do this multiplication, that's going to be a bigger positive value than this, right? So that's a good indication, not a guarantee, but an indication that we may want to pair the positive with the 7x, because my goal is this big positive number in the middle. So how the heck am I going to think of if this were negative, how would I offset that to get all the way back to plus 64? It just wouldn't happen. All right. Now we can go ahead and think of the factors of 60 that could work here. You may already be able to see it. Maybe we have 1 and 60. We would have 2 and 30, 3 and 20. Let's see what else. 5 and what? 5 and 14. We'd have 6 and 10. And I think that's it. So if I take a look at those numbers, which of those, and 4 and 15 as well, sorry, 4 and 15. If I take a look at those numbers, which of those pairs of numbers is going to get me this plus 64x in the middle? Again, you can root out a lot of possibilities. 60 and 1, good luck with that. 7x times 60, there's no way you're going to get there. Even if I did negative 60 times 1 to get negative 6, it's just not going to happen, right? You could root that out. Same thing with like 2 and 30. 2 and 30 is probably not going to work either, because 30 is just too large. But if you start to break it down and think about it, you would think of, ooh, well, if I did 10 here and 6 here, look at what happens. 7x times 10 plus 70x, negative 6 times x minus 6x, that gets you your plus 64. All right. So it's definitely going to take a little bit of time, a little bit of practice to get really comfortable with this factoring technique for sure. It's going to come faster and a little more naturally the more you do. But I encourage you to keep practicing, because it's an important skill that we're going to use all year. And it's also really easy to check your work, because you should notice that everything matches up, just like we saw here, right? You should always be able to distribute this back to get what you started. That's one way you could check. These middle numbers should always add up to be your middle goal here. That's another way you could check. And you could just check to make sure, is 7 times x equal to 7x squared? Negative 6 times 10, we get negative 60. So there's a lot of ways that you can go back and check your work when it comes to factoring. All right, hopefully that made sense. We're going to continue our factoring discussion on Thursday, on which that day we're just going to do probably 10 factoring problems. Just go one at a time and just make it through all 10. 2 minutes per problem. It'll be a great day. All right, we'll wrap it up on Friday and have our progress assessment next week. Thank you guys so much for your attention and focus today. I hope you have a great rest of your day, and try those practice problems on Google Classroom. Always good to try more and more factoring practice. Take care, everyone.